Hi everyone, welcome to Eve Math Tutoring. Today's lesson is on factoring quadratic trinomials. So quadratic trinomials are in the following form. And factored in the following form. However, I'm going to be showing you an example to make this a little bit more straightforward. Okay, so in a previous video I had done an example, the following example. So 2x squared plus 5x plus 3. So the question was to factor this. Now we had done a video on factoring regular trinomials, but what happens when you have a number in front of your x squared and you can't actually factor anything common out of these three terms, okay? So this is fully factored. I mean, not fully factored. There's nothing I can factor out that's common out of these three. However, I've got a number in front of my x squared. So when you have a situation like this, I'm just going to show you how you would solve something like this. So you're going to think of two numbers that add to 5, the middle term, and then multiply not to 3, but to 2 times 3, which is 6. Okay, and so those two numbers would, so positive 5 and positive 6. So two numbers that would be positive 2 and positive 3. So what you're going to do then is you're going to replace the middle term with these two. And I'm going to put the 2 with the other 2 because I can factor that 2 out later on. And then I'm going to write the 3 over here, plus 3. And the reason I wrote the 3 here is because I can factor out something common there. But I could have done it in the other order. That would have been fine too, actually. So what you do is you take the middle term and you replace it with those two numbers and you attach an x. And then at this point, what you do is you look at the first two and you think of what can you factor that's common out of here. And the common factor would be 2x, and I'm left with x plus 1. So as you know, when you factor something out, you divide both of these by that thing that you're factoring. And over here, the common factor would be 3, and I'm left with x plus 1 again. And now I notice I've got a common factor here. So I get that x plus 1 common, I factor that out, and I'm left with 2x plus 3. So that would be my fully factored form. Okay, so that would be the fully factored answer to this question right here. And we are going to be doing a lot of other examples. So let's try a different example. Okay, so another example would be if we had the following. So say we had 3x squared minus 16x minus 12, and we want to factor this one out. So again, I'm going to think of two numbers that add to negative 16, the middle term, and multiply to 3 times negative 12, which would be negative 36. So two numbers that multiply to negative 36 and add to negative 16. So let's see here. Okay, so you can think of different numbers, but it's going to take a while. But I've thought of negative 18 and positive 2 works. Okay, so this part might take you a little bit of time. So negative 18 and positive 2 multiply. What you want to do is think of the multiples of the number you're looking for here and see if they add up to this. And in order for them to add to negative 16, I need to make the 18 negative and then the 2 positive. So what I do now is I replace the middle term with these two. So I'm going to go minus 18x plus 2x minus 12. So I replace this with those two. And then at that point, I see what's common here. So from there, I could take out a x. I'm left with 3x minus 18. And now something is not adding up here. 18 divided by 3. Actually, no, we could take out more than that. So we're going to change this part a little bit. So it's going to be, you want to factor out the biggest thing you can out of the first two. And actually the biggest thing I can factor out is 3x, because that would give me x minus 6. So 3 does go into 18, so I could factor it out from both. And then over here, the biggest thing I could factor out of these two is just 2. I can't factor out the x because there's no x here. So that would be x minus 6. Okay, and that's what you want to see, because at this point now you can factor out the x minus 6. And when you do that, you get 3x plus 2. So that would be your final answer there. Okay, so that's a different example. Okay, we can do a few more. Let's do a few more examples here. So let's try 5a squared minus 8a plus 3. The question is to factor. So I want two numbers that add to negative 8, the middle term, and multiply to 5 times 3, so positive 15. So those two numbers would be negative 3 and negative 5. So I do 5a squared minus 5a minus 3a plus 3. Okay, you can do this in any order. You could have put the 3 first. You still end up with the same answer using this method. Okay, so at this point, you can now factor out from the first two of 5a, and you're left with a minus 1. This part here, this part, if I took out a positive 3, then I'm going to get negative a plus 1. And I kind of don't want that because I want these two brackets to be the same. So it would probably be wiser to take out the negative 3. And when you do that, you get positive a minus 1. Okay, so this here can throw you off. So if I had taken out positive 3, this would have ended up being negative a plus 1, and then these two would have been different. So you want to kind of watch out for the signs when you're doing that, okay? So as you see, not obvious, but I took out this time a negative because I wanted this bracket and this bracket to be the same, because ultimately I want to factor those out and write my quadratic trinomial in the form of, a plus or minus something, and then, a number, a plus or minus something else in brackets, okay? So that's the trick there. So if we had taken out positive 3, this would have been negative a plus 1, and then we would have had to factor out the negative 1, and then we would have had these two being the same. So you could just do that right here, right from the beginning, okay? So that's that one there. So I think those are three pretty good examples there to help you understand how to factor quadratic trinomials. You might get situations where you've got, again, like more complicated stuff, but again, the rules don't change. I mean, I could do one as an example. So if you have something like factor something like the following. I mean, if you had something like this, so 12a plus b squared minus a plus b minus 6. If you look carefully, you could just imagine this like an x, and you're still using the same rules, except instead of an x, you've got a plus b. Okay, so for this one, again, we want two numbers that add to -1 and multiply to 12 times -6, which would be -72. Okay. Yeah. So we want two numbers to add to -1 and multiplied to -72, and I think that would probably be 9 times 8. Yep, 9 and 8. So we're going to go -9 and +8. So what you're going to do is you're going to go 12a plus b squared. Keep this in brackets. So plus 8a plus b minus 9a plus b minus 6. Okay, there. So now, at this point, what can you factor out from here? Well, you can factor out a 4a plus b. When you do that, you get 3a plus b plus 2. And over here, I could take out a negative 3, and I get, again, 3a plus b plus 2. Again, I took out the negative 3 because I wanted these two to be the same. And at this point, you get, you could factor this thing right out of here. So 3a plus b plus 2 times 4a plus b minus 3. Okay, so there's that one. I'm just thinking if we should simplify it. Now, because we've got some brackets here, I would say to go ahead and simplify this and open up the brackets. So you'd have 3a plus 3b plus 2, and then 4a plus 4b minus 3. So that would be your final answer. Okay? So that's a little bit different there. So that's another example. Okay, so we can do a few more. So let's try a few more interesting ones. What if we had 5 and we want to factor this 5x to the 4n plus 11x to the 2n plus 2. What about something like this? So again, you got the number in front, no common factors, so you want two numbers that add to 5 times 2, add to the middle term, add to 11 and multiply to 5 times 2, which is 10. So two numbers that multiply 10 and add to 11 are 10 and 1, both positive. So I'm going to replace this middle with 10x to the 2n plus 1x to the 2n plus 2. So the middle gets replaced with that. Okay. So now, what's common over here? Well, 5x to the 2n is the biggest thing I can factor out of these two. So then I'm left with x to the 2n plus 2. And then over here I could just factor out a 1, and that's going to give me x to the 2n plus 2 over there. And at that point we could take out x to the 2n plus 2, and we're left with 5x to the 2n plus 1. So that would be our final answer. Okay, so again, like, it's so many different examples, and it's just a matter of trying them, really. Okay, so that's that one. Let me do one more that I see that I think that would be a little bit tricky. So say you had something like factor 3a plus x to the 2n minus 3a plus x to the n minus 6. Okay, now what about this one? So instead of x, you've got this, a to the x, and then you've got 2n, so you've got n's for exponents. So we want two numbers that add to the middle term, which is negative 3, and multiply to 3 times negative 6. So that's going to be negative 18. So we want two numbers that multiply negative 18 and add to negative 3. Well, those two numbers are going to be negative 6 and 3, positive 3, because those they add to negative 3 and they multiply to negative 18. So what we're going to do is we're going to replace the middle term with that. Negative 6a plus x to the n plus 3a plus x to the n minus 6. So we replace this middle with that there. So now at this point we've got 3a plus x to the we could take out the n, and then we're left with a plus x minus 2 plus we can take out the 3 here, and we're left with a plus x minus 2 again. So now you could just factor this part, this whole thing out here. So that becomes a plus x minus 2 And then a to the, no, that's those three. So this part here is going to be, so that's going to be 3a plus x to the n plus 3. Okay, so we got that part. So, and we can go a little bit further with that. Something isn't looking right to me here. No, this should have a power of n. Okay, so yeah, this one has a power of n attached because we factored out 3a plus x to the n. So there's still an n here. And even here, this has an n too. So there's an n there. Okay. Now it looks better. Now, yeah, so that would be the final answer to that one. So you could take out the 3 if you want. You could factor it out. You could write the 3. You could write it like this, or you could take out the 3. Then you could, like the second 3 there, you would have a plus x to the n minus 2 times a plus x to the n plus 1. If I factor this 3 out of here and brought it over here, or you could just write it in front or over here. So I'm factoring that 3 out of there. That's how I'm getting a plus x to the n plus 1. Okay? And then this part, a plus x to the n minus 2. Yep. Okay. So that would be it. So I'm just going to fix this part here. There. Okay, so that would be the answer there. So that would be it. So that's another interesting example to try out. So there's a whole bunch. If you have any other questions, you can feel free to email me at evemathtutoring@outlook.com or post a question on the channel. Hope you enjoy.